Hi, my name is Todd Carter. I'm a Principal Premier Field Engineer working for Microsoft. In this module, we will discuss the various options developers have in creating custom search solutions. We begin this module with an overview of search extensibility options. We then look at how developers can extend the search web parts and discuss the query syntax improvements. I will go over the new connector framework and show a demo of a custom connector which is used to crawl Twitter. We then move on to talk about refiners and how they can be customized. We finish up this module with an overview of custom ranking models. So let's get started looking at how we can extend search in SharePoint. We start our discussion of search extensibility by first looking at the challenges we faced when working with SharePoint 2007. Some search web parts were sealed, which made them impossible to override or subclass. While the core results web part was public, its interfaces were hidden or sealed. Clearly, these web parts were not intended to be used in this fashion. So for most scenarios, this meant creating new custom web parts or trying to make do with the limited customizations available. Designers could customize the XSLT to format search results, and the core results web part does have quite a few properties which make it quite flexible, but still, for some scenarios, this just was not enough. So let's jump ahead to SharePoint 2010 and take a look at a menu of extensibility options we have available. When I think about all the ways we can extend search in SharePoint 2010, I like to bucket these into two categories: query and indexing. Query extensibility is those customizations which can extend or enhance the user's query experience, the most prevalent of which are the search web parts. As we will see later in this module, there are quite a number of web parts which can be extended through subclassing, allowing you to take advantage of out-of-the-box features which fit your need and combine those with additional functionality your solution requires. In most cases, code-level customizations will use the query object model, federation object model, or the query web service. In a first demo, I will introduce you to a pattern which uses the query object model to extend the core results web part. Custom ranking models allow you to control or tweak how search ranks query results. This allows us to build very specialized search applications where out-of-the-box ranking is not sufficient. Fast allows user properties to be used to customize the results a specific user may receive. This allows search results to be more targeted by considering the user who is performing the search. Search refinements, which we'll discuss later, are a way to group and display search results based on associated metadata. Indexing extensibility are those customizations which can extend what search can index and how it handles those items. As we'll see in our second demo, we can create custom connectors using a new framework, what was previously known as protocol handlers, which allow us to connect to a custom store or location to perform a crawl. It's important to note that while protocol handlers are still supported in SharePoint 2010, this feature is being deprecated, and I highly suggest moving your solutions to custom connectors. Adding BCS content sources, much like what was possible in MOS, is a method you might use to allow search of your line of business data. Fast allows you to plug in custom identity extractors, which allow you to write managed code which is injected into the entity processing pipeline to perform additional property extraction or modification as each entity is processed. iFilters have been around a long time and are still used today. They use a COM interface, and while they are a bit harder to write, they are a very powerful way of extracting data out of entities, such as files with specialized formats. So let's start by taking a look at the extensibility for the search web parts. As I touched on previously, in MOS, some search web parts were sealed, which meant they couldn't be extended with your own classes through subclassing. This left you starting from scratch, writing your own web parts, which meant much of the functionality you may have wanted from the original web part was not immediately available to you. As a sign of how open these web parts really are, the Fast Search team used these web parts as a basis for many of the web parts which ship as part of the Fast product. So the takeaway here is extending the search web parts through subclassing is a proven model, which we expect to see a lot of developers use. Probably the most flexible search web part, and as a result, the one we'll most likely choose to extend, is a core results web part. Through subclassing, we can override a number of methods, which allows us to plug into the web parts processing. We can add additional controls or modify the HTML. If we choose, we can format the search results by customizing the XML response doc, which is the XML document which all search results are stored. Adding additional properties and editor parts allows a developer to include additional configuration points, which can provide additional functionality and flexibility. Being able to modify what is queried is a common scenario. Specifically, dynamic queries based on user context or where the web part is being used within the site allows search results to be returned without the user needing to type keywords into the search box and submit a page to retrieve the results. Instead, the results are returned as part of the page. In our first demo, I will show you how most of these methods are used in action. So let's show an example of just one scenario where a custom core results web part is really useful. The scenario is we want to create a web part which will be deployed to a user's My Site. We want the web part to display the documents which that user has authored. We'll call this web part My Documents. The solution requires that we create a dynamic query at runtime, which takes the user's name and passes it as part of the query which asks search to return documents authored for the user executing the web part. We start this project by creating a class which derives from core results web part. We only need to override one method, which is configure data source properties. This method is normally used to instantiate a data source, but we will use it to inject our query. In our example, we simply format the query to include the currently logged on user's name as the author and to set the query string as the fixed query. The fixed query is used here because we're not looking to the query string to try to pull keywords, since we plan on using this web part on pages that they're not having traffic sent to them from search boxes on other pages. This is really the extent of the functionality. What's impressive is the small amount of code necessary to pull off this feature. And we can still customize the core results web part XSLT to format the results even further. So let's take a look at a little more complex example. Introduce a pattern you may choose when customizing the core results web part. After we finish introducing this pattern, I will show you a demo where we'll walk through the code. A scenario is we want to create a web part that can sort any number of managed properties, and we want to choose what properties are available to sort from the toolpart editor, where the choices are sourced from the available managed properties within search. There are many ways in which search results can be customized using the core results web part. In fact, we just completed a walkthrough showing one example that overrides configure data source properties. This pattern should work for virtually any customization scenario. The first step of the three is where we create a new web part which inherits from core results web part. In addition to overriding configure data source properties, which you saw me do in the walkthrough previously, there are two methods which you will find useful to override. Create child controls is a base method found on all web parts, which allows you to create controls and add them to the web part control tree. If you have written web parts before, you have most likely used this method. When overriding, it's usually a best practice to ensure the base's create child control method is called as well. There are two approaches here: either adding your controls and then calling the base's method, which puts your controls at the top of what will be rendered, or call the base method and then navigate the control collection to insert your controls wherever you see fit. Overriding create data source is how you inject a custom instance, which is what you want to do next. When called, your overridden create data source method should set the data source property on the core results web part. This means that you want to create a custom data source class which inherits from core results data source. The data source class itself is not that interesting. That is, there's not much to override within this class, but it's a gateway into creating a custom view, which we will do next. So our last step is to set up the view. We want to create the custom class, which derives from core results data source view. For those keeping count at home, this is about 3 custom classes that we've created, but it's really not that much code when you think about it, and I'll show you more in the demo. Once we've instantiated our custom data source view class, we set it as our view property on the custom data source. It's in our data source view where we want to ensure we get a reference to the query manager to ensure our view is exposing the necessary functionality needed to make it operate like any other view. Our extensibility point within the view is in overriding the add sort method. It's this method where we can modify almost any part of the query just before it's processed by search. So let's take a look at a demo which uses the pattern we just described.
All right, so let's take a look at our sorted search example. So this is a web part where we want to display a list box or a drop-down box where people can decide what field they may want to sort on. So rather than just returning the results to them sorted by ranking, we may want to sort them a different way. So what we've done is we're going to create a web part that's based that we're going to derive from the core results web part. So we'll take a look at this guy. So this is our web part. This is a normal SharePoint 2010 project. Actually usually create an empty project. I added a web part to this, so not a visual web part, just a regular web part. And then I just changed this to derive from the core results web part. And so I called it the sorted search results web part. Let me zoom in a little bit here. So as I mentioned before in the previous slides, what we want to do is we want to create this data source. So this is the sorted data source class that we'll look at in a second. This is what is going to get us access to our view. So those are the 3 classes we're going to create: our web part, data source, and then the view. So in the web part itself, in the create child controls, we want to go ahead and add a few controls. So one of them is going to be the fields that we're going to sort by. So and then the other is going to be if we're going to be sorting ascending or descending. So there's 2 different drop downs that we're creating. So that's really what this code is doing here. Now once we get down to this, then we get the render. It's pretty simple. We just select the value, set the values, and that's kind of how we're going to do that. So not a lot here. In the render, though, I just did make a note here that if you wanted to change what the output might look like, you've got this XML response doc, which is your XML document that has your response in it. So you could actually, if you wanted to, you could modify that before it actually got rendered back to the client. And then and I'll show you in a little bit, we have a custom editor part that we're going to go ahead and add some additional configuration so you can select what fields appear in the drop down. So user can decide, or you can configure what items you want in that drop down to be able to sort from. So I'll show you what this custom search results property picker looks like in just a second. Let's go back to the data source. As mentioned, the data source is really just a wrapper around our view. So let's move this. So you can see here that I have a sorted data source that I create, and then I derive from core results data source. And we're going to be passed in our parent web part, which in our case is the sorted search web part. Sorted search results web part. Now we're just going to pass that right to our base, which is fine. And then in the view, we're just going to create a new view. Now this is our view that we're going to show you in a second. We're going to pass this pointer, so a reference to the data source. So a view needs to have a reference to its data source. And then we're going to just pass really just some generic name. In this particular case, I'm just using this type's name to pass to it. So just some kind of string needs to be passed to this view. So let's take a look at the view. And really, before I do that, look, this is all there is to the data source. There's not really much going on here, other than we're injecting our view into the process. In our view, we are going to derive from core results data source view. And this guy takes a couple of those parameters that I was showing you before, the data source owner, which is going to be the search results base data source, which we're going to cast to our data source, and then the view name. So this is that string that I just passed in, which was the type name. So pass those to our base, and then in our I'm going to use once I pass that into our base, the data source owner set for us, and so I'm going to cast that to our sorted data source. Now the sorted data source has something interesting that we want off of that, and what that is it's actually the parent web part. So the parent web part has a reference to the page. Okay, so for the page, if we want to, in this particular case, for a view, we need to set up our query manager. And this is not something we're going to use in this particular example, but it's something that every view needs, is for the query manager to be derived and then injected into this property. So we're just being good citizens here by doing that. Otherwise, we would fail. But the way you do that is go to your data source and get the parent web part, and then from that, you probably want to grab the page. And then using that, you can actually, using the page reference, you can get the query manager off the page. And that's really what this code is doing here. Again, nothing we're really using. Then we have this. This is the guy that's really doing a lot of our work for us. This is the add sort order. So this is an override. Now, what's going to happen is we're going to be called, this add sort order is going to be called, and then we can do anything to format the query right before it goes to the query server. So in this particular case, we're going to actually do what this method says, which is the add the sort order. Now, as I was kind of inferring, you can do more than that. You can do any number of things, changing the query, changing scopes, things like that. But in this particular example, we're actually are going to be modifying the sort order. So what we're going to do is we're going to clear any current sort order that may exist. Then we're going to get using the data source owner, again the parent web part, we're going to cast that as our sorted search results web part. And so we've got our web part now, which derives from the core results web part. And off that's a property we've called sorted fields. Or sort fields, and these are the fields that we're going to be sorting by. So what we can do is we can actually go through here and determine what if they've been set to something. So if they've been set to, if we go in here and look into the form, the page, web part page request the form, if it's a postback, we'll go and get the direction. So we're getting into getting the name basically of the form property, which represents our drop down for the ascending or descending combo box. And we're going to, so if it's set to ASC, we're going to use ascending. Otherwise, we're going to set descending. Then what we're going to do is we're going to add, we're going to go grab the same thing, the sort field. So this is the field that we're going to use to sort by, and we're going to set that direction. So we're getting the name of this guy and setting the direction. And so when you do that, you're adding that sort list right into here. Otherwise, if it's not a postback, we just want to basically just break out and take the very first entity, so very first sort field that we have configured. So that's the default and the drop down, and we'll go ahead and just we'll go ahead and just set that guy as our current value, and we'll set it as descending. So I'll show you what this. It'll probably make more sense when I show it to you later. Otherwise, we're just going ahead and add a just call into the base add sort order, which is not going to do much for us in this case. And then I have this custom. I have another property on here just to show you could do other things. I'm not going to use it here in this demo. But so I create this property. It takes a boolean and it says only show my authored. And what I really wanted to show you, this was much like in the walkthrough I showed you before, where we actually modify the query. In this particular case, you can see here, I can actually append to this query. So any query that we have that's populated here, you notice I'm appending to it here. So what that, again, trying to show you here that in two cases, I've modified this query using this add sort order. So like I said, anytime you want to mess with this before it heads over to the query server, this is where you do it. So I've showed you the view, showed you the data source, and I've showed you a little bit of the web part. Let's go ahead and take a look at this down here. which is our editor. Now this guy uses a couple things. So what you want to do, there's three methods here. The create child controls, and really all this is doing is just setting the title to our editor part, and we're setting a label to our editor part, and we're adding that, and this is really just a kind of a description of what you want to do. And then we've got our panel that we're going to use here in a little bit that we're going to add our additional controls to. Now that panel, that's why we kind of hold this reference here, because we need to kind of have that reference because we're going to add those things. So what's going to happen is the first time this is loaded, this create child control is going to be called, and then the sync changes is going to be called. And so in the sync changes, what we want to do is we want to get the web part that we're going to get a reference to our web part. In this particular case, it's going to be stored as the web part to edit. So we're going to cast that to our sorted search results web part. Then we're going to look and see if that web part, the property, has any sorted fields. The very first time, we're not going to have any, so it's going to be null, and that's kind of where this code handles this. But where we have sorted fields, these may be fields where we want to sort by. In the example I'll show you later, I want to sort by a few, and so this will hold potentially three different fields, and then we're going to split those on the semicolon. So we're storing this as a string, and we'll store our selected sorted fields here. So these are the ones we've selected to be allowed to be selected from the user. So there's first level selection is selecting from all of the properties available to sort from. Once configured, then the user can select from a drop down of what values they may want to sort by. So we want to go ahead and get the properties, the managed properties from search, and that's what this code does. So we need to ensure we're running as the app pool identity, so we're going to do a run with elevated privileges. And then this code is really around getting our service context and then getting our proxy. So once we have our search service proxy, then I want to get the service from that proxy. And the way I do that is in this code here, where I'm just going to use a little link here and get the where my search applications, where the proxy name is my proxy, which I've received here. I want to put that right into here. Now there should only be one, so it's pretty safe just to call the first here. At this point, I've got my search service application. With that reference, I can then grab the schema, and then from the schema, I can actually dive into the managed properties, which is this all managed properties collection, and then I use a little more links here. And what I do is for each managed property, I want to make sure it's a text. So in the cases here is I want it to be text. I want to make sure it's not a multi-value, and I want to make sure it's part of the document properties, and then I want to make sure that we're allowed to store more than 0 characters. So it's pretty much we want to make sure the property we care about is a text property that has a single value, and we're allowed to store multiple characters in that value. And then what we want to do is, or we can actually choose fields that are either date, time, or integer as well. And so those are all going to appear. So text, date, time, and integer fields are what's going to be available to us. Then what we're going to do is, from that, I'm going to create a new anonymous type that's going to have a display name on it. It's going to have enabled for scoping, and we're going to have a managed type. So this is the managed type name, and then the property ID. Then what we're going to do is, and then of course those are then stored into this array of these special properties that are this anonymous type. So by doing that, what I do is for that property, I've got this property collection. Now, this is that type that's going to be anonymous type, but reaching into that, I can actually use IntelliSense and still get to the display name. So what I'm going to do is instantiate a new search list item. This is I'll show you what this looks like in a second. And what I do is I use this guy, and if we have fields that may have been previously selected, I want to make sure that I show that guy as checked. In other words, the scenario would be you would go into here, you would have a list of all of these checked, these fields that have checkboxes next to them. You check off a few of them. You save, apply changes, then you go back later and go to edit. You want the ones that you chose previously to still be selected or checked, and that's what this code is doing here. And then using that reference I stored before previously, we're going to add these to our controls. So to our our panel has a list of controls, and we're going to add each one of these to it. So it's probably good to go look at this right now. Let's go look at the this search list item. So this is going to have a label and a checkbox. So it's just a div. So what we're doing is we're deriving from HTML generic control, which means what that allows us to do for ASP.NET allows us to create any element we want. In this particular case, I'm going to create a div element, and then within there I'm going to have a checkbox, and I'm going to have a label, and that's what I'm doing here. Now, notice here, for the ID and the name, I want to use this special asterisk here. This is how so we can find these later. Now, when I'm doing this, my checkbox, my special checkbox, notice I'm not just passing in the ASP.NET checkbox, I'm doing this search list item check. And I'll show you why. The reason I'm doing this is because it's an input checkbox, but when you have a naming container, and by default these all have naming containers, they'll be custom, they'll be named for us automatically by ASP.NET. And what that means is that the name of the actual object will get the name as part of, when you have a master page and all these different levels within the hierarchy. What will happen is your control will be uniquely named, and we don't want that here. So what I pass back as a null for my naming container means I own my naming of my control here. So for this control, he owns his own naming. So don't try to give him a unique name. We'll make sure it's unique for our case. And that's what that's doing. And that's why I'm able to set these guys here and then be able to stick, is because of that. So notice I've created this special looking name with this asterisk or star in front of them, and that way I can find them later, and I'll show you where we do that. So then I have a label, and then for the checkbox, I go ahead and just bubble that up as a property hanging off of this, and just a checked boolean, and I just set my checkbox checked property or not, or and return it here. So that's kind of what I'm doing here. So this guy's kind of encapsulating a label and a special checkbox that we can control the naming of. So once I've done that, like I said, we've got to go through there, determine which ones are selected, and set them here. So that's really what this code is doing. Let's go back over here. So we've kind of explained that. So I think we've got everything. Let's take a look at what this looks like. Let's go ahead and deploy this. So it's building it, deploying, it's recycling IS, and there we go. So it should be, it's adding the solution now. Activating features, deployed succeeded. Okay, so let's take a look at what this might look like. So I have over here, I have a search center. And in my search center, I have just the out-of-the-box search center with a results page that's just using the out-of-the-box core results web part. And so what we want to do is we want to substitute and use our new sorted results web part in its place. So we'll do that here as soon as this comes up. Okay, so let's take a look out of the box what this looks like. Okay, so I just did a search for SharePoint, and this is the out-of-the-box, kind of what the results are going to look like out of the box. But in our particular case, we want to change this. So I want to go to the page. We want to edit this page, and we want to go ahead and remove this web part here. And then we want to go ahead and add a web part. Scroll up here. And there's our sorted search results web part that we'll add. And then we can just stop editing. Now, you notice it's not very impressive, nothing's really changed, but what we can do is go in here and edit this web part. So we load our editor part. and then scroll over here. Now this is that new panel that we added, that sorted search results. And remember that label that I added that kind of gave a description of what we're going to be doing here. So here is all the properties that we pulled that are managed properties that are either of type text, and remember I showed you that need to be text or need to be part of the dot properties, or the number of characters need to be more than 0 that we could store. So these are the ones that are either that text or integer or date time. So a couple things that we can do here is just we can go through and look through this list and say, okay, great, there's a few of them that may be of interest to our users. And so what we'll do is we'll configure these to a few of these to allow the user to select those. So we'll select last modified time, we'll just do rank and maybe size. And then we'll just save this. And then what we'll do is we'll refresh this page. Or actually, we'll just do this. Here we go. So now what we've done is we've added these two drop downs. The drop down, this first one, is the field that we're going to sort by. And this is where we went through and found the items that were stored in our property, our custom property within our web part. And we've got last modified time, rank, and size. And then we have that ascending or descending here. So in this particular case, if I just wanted to do last modified time descending, I could do a search. And you notice this one's changed on March 25th, or I can do a ascending, and you notice this one was back in January when it last changed. So pretty simple web part. We can go do the same thing with size. Take a look at something. If we want to look at our smallest, we can see this one is going to be the smallest, even though size doesn't show up here. Or you can do a descending, and so I've got size on some of these items. So this is 104K and this is 96K. So that's a way you can actually add some additional controls to the core results web part that actually add functionality that allow the user to refine, much past what you could do here in the refiner. It actually allows you to display how you want the results to be sent back to the user. So just a very interesting web part that really we couldn't have done this, or it would have been very difficult to do this in 2007. And so by opening up the view and the data source and really the web part itself, using all of those together and using the pattern I kind of showed you there, this is actually a way that allows us to do this, which is much easier than what we could do in 2007. So this completes my demo. Thanks.
Next, we will discuss some of the query syntax improvements made to SharePoint 2010. SharePoint 2010 has a much improved keyword query syntax. We support adding operators right into the keyword syntax. We also have a prefix matching for keywords and properties, so you can search for part of an author's name, such as Bill, and use a star as the wildcard. Note that we are still using suffix wildcards. Like previous versions of SharePoint, we still do not support prefix wildcards. We have also extended our operator support to include common operators and include greater than or equal to and less than or equal to. One of the other things that come up when you write a custom search web part is the query that you want to send to search. So one of the things we don't do out of the box is give you access to a full text query object. We give you access to a keyword query object, but in the past, this was not always enough. So what you may have found was you needed to drop down to using the SQL syntax to properly format your query you wanted. So in SharePoint 2010, with this extended keyword syntax, there are going to be fewer times that you actually need to use the SQL syntax. So here is an example of the out-of-the-box advanced search web part. Many of the elements used to require SQL syntax to format your query. So let's start at the top. So if you want to do a search where all words are included in a document, I use the construct all and put the words I want within the parentheses. If I want to ensure an exact phrase is used within a document, I just put quotes around the phrase. If I want a document which may contain any set of words, I use the any construct and put the words again within parentheses. If we want to exclude documents which may contain a word, we can use the new construct none. So when wanting to use a scope, it's much like we did in SharePoint 2007. We use the scope keyword and tell search what scope we want. If we want to use a specific language, we use the detected language equals and then specify the language code we want to use. So in this case, I used EN for English. If you want to look at a specific result type, for example, you want to look for Excel documents, you just use the file extension keyword, and then you specify the extension of the documents that you want returned. In our example, we use XLS and XLSX to denote Excel documents. Note in this example, it actually makes use of the OR Boolean support within our keyword syntax, which I discussed previously. And finally, we have our property restrictions, which are much like what we had in 2007. We can take a managed property and limit our results based on those properties. So this example, we're actually looking for all documents which have the author Steve Peshka. So when we put this all together, the yellow text in the middle of the screen is what the keyword query will look like when we send it to search. Let's move next in introducing the connector framework. As far back as Site Server and then in SharePoint 2007, protocol handlers have been used to gain access to crawled content. Search took advantage of the new product in SharePoint 2007 called the BDC. It specialized in interacting with data and complex external data repositories. Search made use of BDC to index data from databases and web services backed by repositories. There was a significant payoff as the new technology enabled crawls of back-end systems by just expressing connections to repositories declaratively in XML without having to write any code. Protocol handlers use an unmanaged COM interface, which directly plug into the search indexer, making a highly performant way of indexing data from customer repositories. SharePoint 2010 search team decided to dramatically simplify what was needed to crawl external content. While protocol handlers are still supported, it's encouraged to use this new managed code connector framework. With the connector framework, search leverages the BDC runtime and a model as a way to connect to the external data. The connector framework uses a BCS connector, which implements the System Utility interface. It's this interface which your custom connector must implement and which search will call into to retrieve your proxy. Custom proxy class is used to retrieve the data from the external system. The class is defined using the BCS metadata, which defines the line of business system, model, entities, and methods. The BCS model also defines the inbound and outbound URI processors, which are responsible for handling the starting URIs and the URIs returned for the entities. Using the BCS connector, you can return attachments. Support for item-level security is available by using .NET classes to return ACLs. You can also use the BCS connector to crawl across entity associations if defined within your model. As I will show you in the demo, you can control the URL which is returned to search, which will be used for accessing the crawled entities. Also in the demo, I will show you how to use PowerShell script from .NET code to create and remove a custom connector from within a feature receiver. So let's jump right into the demo.
Okay, so let me start this demo. This is a Twitter connector demo we're going to do, and what I have is I've built a SharePoint solution, called it Twitter connector, and really it's just a empty SharePoint solution, so nothing special here. What we've done is I've created obviously several source files here, and we're going to create a custom model, which I have here, and I'll show you all of that. And so the scenario we're trying to build here is we're trying to build a search connector that will actually search several Twitter accounts that we may want to provide. So we're going to start with this model. I'm going to walk you through that, and then I'll walk you through all the source code. But the project itself is pretty simple. It has one feature. This is a farm level feature. So what this means is our project itself is a farm-based solution, so no sandbox solutions here. And then I have my feature receiver, which I'll show you in a little bit. And let's go ahead and show you the model. A couple things real quick. I have a couple mapped folders here, as you can see by these icons. This one is just for an image that I use for the feature. Just to actually makes it easier for me to find the feature in the list of farm features. And this one is to a Twitter model. Now let me show you where this actually resides. So you have to provide this model.xml, and underneath the 14 Hive under config, there's a search connectors folder. So what I've done is I've created a map folder to that, and then I've created a subdirectory called Twitter connector, and then that's where I drop my model. Now this model, take a look at this guy. Let me zoom in a little bit. Let's collapse this down. So this model is the same schema as just a normal BCS model, and if you guys want to know more about that, there's another module for Ignite that talks about BCS from IT Pro's perspective in the IT Pro BCS, and then there's a BCS for Dev. So underneath this we have a line of business system. Underneath this guy, very important properties here. So let me kind of collapse these down. I want to show you these properties. These properties are what are going to allow search to discover your line of business system and use it. So we have a system utility type name, input URI processor, and an output URI processor. Now these are all of system.string, and they're going to connect to three classes that we have. Now let's kind of show you. These are in my Twitter connector assembly, and they're all the same version, culture, public string. So this is all going to go in the GAC. And so I have three classes here. My Twitter connector, which is really just a wrapper around my proxy, another class that I'll show you. The Twitter line of business URI. So this is a class that derives from LOB URI that I'll show you. And this actually is going to process the incoming URLs. And then the outgoing URLs, the URLs we want to publish, this output URI processor, which is my Twitter naming container. This class is actually going to publish what URLs we want users to be able to see and navigate to. So it'll be a little more evident, I think, in just a little bit when I show you those. Now, what I want to do is I want to show you, continue on here. Here's our instances. So I just create a Twitter instance of our line of business system. Nothing special there. And our entities. And I really only have one entity, and we call it a tweet. And then in here I have a special property that I want to call out. It's called title. And there is a property hanging off my tweet object called message, and I want to mark that as the title. So this is the title that when we index, it's going to be this string is what's used as the title of the what's returned in search. So when you search for something, you know that you get back a title, maybe even an abstract, and then some other metadata like the date, time it was authored or created, and in the URL. So this is kind of just hooking up that title property here. And then I have an identifier, like we're always going to have. And then I have a couple methods. So one's going to be called get all tweets, and one's get specific tweet. Now this get all tweets is going to return an array. So it might return an array of these tweets. And I also want to make sure, it's very important, I mark this as a collection. So I've done that. And then if I go down and dig into this a little bit more, you can see my tweet has an ID, a URL, a when sent, and a message. So this ID, as you saw previously, is my identifier. So this is my primary key, if you will. Scroll down a little bit here. I've got a couple things. So I've got these method. Well, let me go back up. So let's get all tweets. And then here's get specific tweet. Now this guy is going to take an ID, and based upon an ID, return a specific tweet. Again, the return is going to be the same. So this is really just a copy and paste of what you had before. A couple things just to point out that for search, as you know, this last modified timestamp field, which is just like we had before in BDC, is kind of the indicator to search that, hey, use this guy, which is in my case the when sent property, use this guy to determine the date time field of when this guy was created or when it was last updated. So when we want to do an incremental crawl, this is the timestamp field that search will look at to determine that. So that's really our model here. Let's go back over here, look at some code. So the first thing I want to show you, let me just dive in here and give you an overview. So here's the classes I want to show you. So the connector, which I showed you, was one of those of the three items that we defined in our model. We have our connector, we have that line of business URI, and the container. So let's look at the connector class first. Twitter connector. And as I mentioned, let me zoom in on this a little bit. As I mentioned, it really is just a wrapper around our proxy. And so I'm going to create this Twitter proxy here, and I'll show you what that looks like. This is my implementation. This is the guy, if you think about it, it's really the heart of what's going to go after and grab your content from your external line of business system. So this is really, the proxy is really what's going to reach out, grab that data, and then return those line of business applications. So this connector is what search uses and to instantiate these proxies. Now, what I've done is I've actually derived from this structured repository. Let me go back over here. Structured repository system utility, and then I pass it. It's generic, so I pass it my Twitter proxy. So when they call create proxy, that's kind of how he knows what type is going to be returned right here, because it's part of a generic. So I override that, and then the set connection string. So the connection string is going to be coming in from this connection string is what's going to be coming in from search. And so this is if you think about, these are the starting addresses, and I'll show what those look like in a little bit. But starting address, so as you know, when you configure a content source, you have to give it the starting addresses. So for example, if you're creating an external content source to crawl, let's say www.microsoft.com, you're going to go in there and put http://www.microsoft.com. And so this is the connection string here that's going to be passed in to our proxy. So then we're just going to set that connection string, and we're going to call connect on our proxy, passing in that connection string. Now the rest here I've just kind of hid. These are all just, it's an abstract class that we're deriving from, so we need to override these, or else we get kind of errors. We get some errors. But this is where you'd set credentials and proxy information if you wanted to support that. I'm not doing that here, so it's not necessary. If your proxy was a proxy that needed to be disposed, this is where you dispose of it here. So you hold an instance of your proxy, then when you get called to dispose the proxy, you would then call either the dispose method if you implemented iDisposable, or whatever custom method you want to get rid of the proxy itself. My proxy is pretty simple. In fact, you'll notice I didn't even hold a reference to the proxy. I'm just returning a new instance of it because I only get called once here. So that gives you an overview of what the connector looks like. So let's take a look at our proxy now. Now this is, again, as I mentioned before, this is the guy that's going to go after, and he's going to hit Twitter. So it's going to use the Twitter REST API. So if you're not familiar with that, it's just a very simple REST API that's supported over the internet, and anybody can use it. Now it doesn't take any special logon. What I'm doing is just going and getting various statuses, or various tweets, if you will, back from Twitter. So there's not any special logon that needs to happen. And so right here I actually create a cache. The reason I do this is a couple reasons. One is whenever you call get all tweets, what I'm going to do is return all the tweets back to search, and then what's going to happen is I'm not really handing back just the IDs, I'm handing back the entire tweet. So what's going to happen is search is going to go for every tweet that I give back, he's going to ask for specific tweets. In other words, based upon the ID. Well, since I've already retrieved them, let's go ahead and just cache those and service those from my cache. So that's one reason to make it a little faster. The other reason is the Twitter API has a limit on the number of calls that you can make. So what will happen is if you try to index, you know, like 40 people, 40 different Twitter accounts, and then they have, you know, any number of tweets, you'll actually end up running out of, you can't call into the REST API that much from a single IP address. So just something to be aware of, that you'll run into that. So here's my connect that I call. So this is passing in, again, that starting address. I use a regular expression to break that out. Now my starting address is, actually I'll just type it in here. So, um, so for example, what I'll do is I create a protocol, and this is any protocol I want to call it. So I just called it Twitter, and colon whack whack, and then what I do is just that's a Twitter handle or logon ID. So that's mine for Twitter. So this is what gets passed in, and so this regular expression actually parses that out, finds the screen name, and that's effectively in this case Todd CA. So that's what'll be passed in here. So then when get all tweets is called from the crawler, I'll create a new dictionary, and then what I'll do is call execute this Twitter request, passing in the Twitter user timeline URL, and I just kind of append that with the screen name, which is again Todd CA. And I call this execute Twitter request. Now this guy is what's actually going to use that REST API. So I'm just calling into an HTTP web request, very simple. I get back a response. I then take that response stream and put it into a reader, and then I use a link, XML link here, and then I load that reader, and then that's what's going to actually execute that. Now, here's kind of what I was telling you before. If you get back a 400, that means your API limit is probably you probably hit your API limit. So if you're playing with this, just something to be aware of, that you probably want to maybe put a breakpoint in here, and if it gets hit, then you know you've probably hit that limit, and you just kind of wait 5 minutes, go get a coffee or something, and then it will return for you. You'll have a new set of calls that you can make. Now, once I've executed my Twitter request, um, I have this doc, and then I call this parse tweet. Now, I do that in both cases. So in this case, I'm going to do a for each, call parse tweet, and then add this to my dictionary, and then return that. And then, of course, I add that to my cache. Or in this case, the same thing. If I do a cache miss for getting a specific tweet, what I will do is I will actually execute the Twitter request and parse and get that exact tweet that I want. So this parse tweet, all it's going to do is take my X element and convert that into my line of business application, or line of business object, which is a tweet. My tweet itself is very simple. It takes the ID, URL, when sent, and message. And 3 of the 4 are strings, so there's not really much to do. This when sent, though, there's a little extra work that I need to do here, and I'll show you why. So this particular case, what I'm doing is I'm taking the ID, map it to ID, the text is mapping to message, so those are simple. Same thing here with the URL. Now the URL, what I'm doing is I'm taking my screen name, and I've got a different format, URL format. So here is the URL, the status URL format. So if I want to use twitter.com/the screen name, statuses, and then the actual specific ID, that's one way to actually get into a specific status. If you want to get back a specific tweet, and you know the ID and you know the person's name, that's how you would get that. And that's really what I'm doing here, is just kind of formatting that ID that matches directly to, or the URL that matches directly to this specific tweet. Now, what I need to do, since I get this created at back, which is really the when sent, or when the tweet was created, I need to format that, and that's what this format Twitter date time does. So Twitter has a different format that comes back, and so it's in this format. So I need to parse that out and parse that into a date time that .NET understands. So that's kind of what's happening there. So I've got my tweets, I've handed those back, and that's really what that's really what the proxy is doing for us. So we've gone over the Twitter connector, the proxy, the tweet. let's take a look at this. This is really our incoming URL handler. This class, not very complicated, but it's something we need to kind of dig into and show you how it works. You need to create a class that's going to derive off this LOB URI, and as its constructor, it's going to take a protocol. In our case, as I mentioned before, I'll show you this again. Our protocol is going to be Twitter, is what we're calling it. This is anything that you want, though. So this protocol is going to have to match whatever the user is going to put in for the starting address. So just keep that in mind, that probably something you want to use here, and you also probably want to document as well. Now, from that, what I'm going to do is I'm going to call in and get my line of business system. So I'm getting a reference to my line of business system. So this means the model has been instantiated in the BCS, or actually the BDC runtime, and so I'm just getting an instance of that. Then I'm going to be called initialize, and really all I'm doing is saving off the source URI, which is the URI that we before, that's the starting URI that's going to be used. And then I also get references to the entity here, so I save off the entity, and then a few other things here that I also want to get reference to. The reason I want to get references to all of these is because this class is going to be used by search to understand what the entity it wants to crawl, the identity it wants to crawl, the entity it wants to crawl in the system. So what I'm doing is I'm just trying to hook all of this stuff up for search, pulling this all from the BDC runtime because I kind of know the name of it, and pull it all in, and then at that point I can then allow the search can then crawl that. So that's really what this class is doing for the most part, is just kind of loading all these up for this guy. So not a lot here, but something to be aware of. So the source URI again is the Twitter : whack whack and then the name. Now the more interesting class is what do I want to return? So for every Twitter or every tweet, if you will, that gets served up, we don't necessarily want to take folks to Twitter : whack whack and then the name. So we want to instead take them to the URL where we actually can see the entire tweet on the Twitter's website. So what we need to do is the get display URL. So this is URL that's going to be displayed to the user. Well, we're past an entity instance, and what we do is we take an adapter object off this. Now, normally you wouldn't use this adapter object, especially if you're writing a line of business application that you would potentially be using on client application on the client side, such as when you might use it inside of Outlook or something. But in this case, we're pretty safe because we're all in the same process here. So I can actually take this guy and cast him to my tweet, and then my tweet, that URL in my tweet, is going to be my display URI. And so that's kind of how we kind of wired all that up already. So not a lot there. Again, a lot of this stuff is pretty straightforward. So once I have my get display URI, there's several overloads here, and all I'm really doing is getting all those here. Pretty simple stuff, not a big deal. So let's go ahead and we'll close that down. So really, I've showed you all the code, other than how we actually register our connector with SharePoint. So for right now, let's go ahead and I'll show you that in just a second. So let's go ahead and get this thing deployed. I'll go ahead and build it. So build succeeded, and let's go ahead and deploy. Now we'll deploy, and we'll get the Twitter crawling. We'll get our new connector crawling, and then I'll show you what the feature receiver looks like. Okay, so our deployed succeeded. We're good here. So let's go to the farm features and make sure our feature is there and activated. And it is. There's our Twitter connector, and there's that image I showed you before. So it's activated and running. So then we can go into the search service applications. I can do new content source. Now I'll just call this, we'll call this Twitter. And here is our custom repository we want to select. And then there's our Twitter search connector. We'll select that. And then now down here, what I can do is, this is where I would add my starting addresses. So here's some starting addresses of some guys that I like to follow. They have some interesting things to say sometimes. So I'll put those in here. Now, again, we can put as many as we want here. I can put one or you know, very many. So in this case, I've put like 5. And then what we'll do is I'll just go ahead and start a full crawl. Okay, so that's starting. So so this is going to crawl a little for a while. Let me go ahead and show you that feature receiver. So how do we install this? Um, installing a connector or registering a connector is done by PowerShell. There's really not any other way of doing that. So there's really not an object model that we can actually hook in to do that. But what we can do though is use object model code to call um, into PowerShell. So that's what I've done here. So what I'm doing is we've got 2 things to install. One is to actually register the connector, and the other is to register the protocol. So here's what the registering the connector looks like. So new SP Enterprise Search Crawl Custom Connector. We pass the protocol. In this particular case, it's going to be Twitter. The model path. So this is going to be the path to where we installed the XML model. And that's remember I showed you before under the 14 Hive under config search connectors Twitter connector, and that's our model.xml. Now what I do is I have this utility that I wrote. Utility class is going to get the Hive, the 14 Hive root folder for me. I just pulls it out of the registry, and so I just combine those together. That gives me my full path, not a relative path. It needs to be a full path to my model. So that's my protocol is Twitter. There's my model path, and then my connector display name. So this is the name that you want to appear in the search UI that you saw previously. And then we want to get our current search service app name. So from, you know, search can have many service applications. So what we want to do is just get our first, I'll show you what that looks like. This is, so what I do is I'm going through and really what I'm doing is I'm just finding the first search application that I have, search service application proxy that I have, and returning the display name of that. Now, this will not work, obviously, if you have multiple service application proxies and you may want to use you know, another one, maybe the second or third one. This is going to return the first. So keep in mind you may not want to use this code for every case, but for this simple example, it works fine for me since I only have one. Going back, so what I do then is since I've got my string that I want to call, I'll call this run PowerShell. Show what that looks like. And so run PowerShell is pretty simple. Once you have the right references added in, you can call this, actually the reference is system.management.automation. You can create this run space factory. You create a run space, and then you open that run space, so effectively create a connection, if you will. Then you want to create a pipeline. And this is where you actually add your source code that you want to run. In my particular case, I'm going to create a pipeline. I'm hard-coding this to adding the snap-in for the Microsoft.SharePoint snap-ins, and then I'll invoke that. So what I've done is, if you think about it, I've just maybe typed something in a command prompt and then hit enter, and that's invoked that. And so then what I do is I create another pipeline, which is that string, which is the actual PowerShell that I want to run or execute. I'll then create that pipeline, and then I'll invoke that, and then the results I just pass back into here and return the results. Now, I don't ever use these or look at these results. It's just that's just kind of the pattern I use to create this. So that's going to execute the PowerShell. Now back over here where I said the second step is going to be installing the custom protocol. Now this being passed in is the Twitter string, and that's right up here. And what I'm going to do is I'm going to open up into the registry my protocol handler registry value, and show what that looks like. That's this guy here. So under HT local machine, software, Microsoft, Office Server 14, search, setup, protocol handlers. Once I open up that key, then what I want to do is I want to add a new value. So this is going to be Twitter, and then it's going to be my new value, and then I'm going to add this 014 osearch14.connector-protocol-handler.1. And then in the uninstall, I actually just remove that and delete that value. But this is the way you tell search, hey, by the way, this is my new protocol handler, and so that's kind of my new protocol that I'm supporting. So that's how you do that. So at that point, once you've done that, you've installed your connector. Now the uninstalling is much the same way, except in this case I'm using remove custom protocol handler, which is just deleting that registry key. And then for the PowerShell, I'm using another commandlet called remove sp enterprise search crawl custom connector, and passing the identity. And this identity is going to be the protocol name. So kind of something different here, right? So if you look back up here, I passed in protocol to install, but it's called identity when you go to remove it. So just something to keep in mind. So unfortunately, we didn't keep the same naming there. Search application's the same parameter, so we just want to pass that. And again, I just called into my utility to get that name. So that's kind of how that works. So at this point, let's go back and see if we finish crawling. Okay, so we're finished crawling. So let's go ahead and see if we can do a search. So I've done a search previously for SharePoint, and you can see the results. I received back a number of results, but maybe not what I'm looking for. So what I can do now, since we've done a crawl at the Twitter account, so what I can do is do a search for SharePoint, and now notice I get some additional items. So for example, here's a tweet for congrats to all the new and renew SharePoint MVPs. So this is done by Spence, so I can actually, you notice the URL here. So I crawled this, so this has all been crawled, but I didn't actually crawl HTTP. I crawled through my proxy, but then I can actually redirect them over in HTTP to the various tweets. So here's one from Ted Pattison. Again, you can just jump through these and take a look at them. So that's kind of how the Twitter connector works. Pretty interesting, pretty nice to use. One thing I will mention, if you're developing one of these and you are going to debug, normally what's going to happen is if you were on this project, if you were to hit F5 and try to debug, you're going to attach to the app pool that you're deploying to. Well, unfortunately, a couple things about this are the app pool that I set. Let me just show you the app pool here. You need to make sure you set your app pool to your central administrator URL. So that's what I've done here. So that means I can then debug my feature receiver. So that's only part of it, right? So the other part I might want to deploy, I want to debug is my connector. In that particular case, you need to manually attach to the MSSDMN process. Now that's a search daemon process. That's the process that's going to load up your assembly. So you need to manually attach to that. So in fact, what you may want to do is that process isn't running all the time. So when you hit F5, or when you just go ahead and attach to process, you need go ahead and set your breakpoints here, attach that process, and then if the process isn't there, you need to kick off a crawl, and then once it appears in your list after you're attaching your process, I just show that to you. So do attach to process, and then you want to make sure these two boxes are checked. Select M here. I just typed in the M, and you can see here, there it is. So I can attach this process, and so that's the process that's going to load up your connector. So it may be that you miss your breakpoint the first time, because this guy starts up, he's going to load your connector and just start partying on that connector. Well, you may miss your breakpoint. So what may happen is you need to set your breakpoints, attach this process, and you may need to kick off the crawl again or cancel the crawl to pick up where your breakpoint may have been hit. But it's not too bad, just something I want to call out and make you aware of, because it is a little tricky and might slow you down a little bit. But that is this demo, and I hope you enjoyed it.
In this next section, we will discuss how to customize search refiners. Search refiners are a way to group and display search results based on associated metadata. In SharePoint 2010, we have what are known as shallow refiners, which use associated metadata from the top results returned from a query. In FAST, we expand this concept further to offer deep refinements, which uses metadata available from all the search results returned from a query. Part of the power of these refiners is the ability to scan the refinement list and reissue query based upon the refinement category. For example, if the document type refinement showed that you had 40 Word documents out of the 100 results, you could choose to reissue the query and filter down the results just for those 40 Word documents. SharePoint 2010 implements the Search Refinement UI with the Refinement web part. This web part uses a proprietary XML document to define the filter categories used to define how query results will be refined. By default, these categories can include title, description, file type, and map property. Filter generators are used to aggregate the results and format the refinement query should the user decide they want to refine the search based on the refinement. Out of the box, SharePoint 2010 ships with 3 filter generators. The Managed Property filter generator allows for refinement based upon a managed property, and in this filter, which is what we'll use later in this example. The Taxonomy filter generator uses taxonomy data to generate its refinement results. The Ranking Model filter generator uses a ranking model to generate its refinement results, which we'll talk about more ranking models near the end of this module. If none of the out-of-the-box refiners fit your need, you can write your own custom refiner by deriving from Refinement Filter Generator class. In most cases, however, the Managed Property filter generator will be the filter of choice. So in our example, we want to add a refiner which allows users to get a sense of the file size types of the items returned in their query, and then be able to drill down on those. What we want to do is categorize the size of the files into several ranges, such as tiny, small, medium, large, and so on. We start by editing the refinement web part properties, more specifically, the filter category definition. This is an XML document, which when we look at it is pretty self-explanatory. In our example, we start by adding a new category element and setting a few attributes, like title, which is the name which will appear on the UI, and type, which is the full path to the Managed Property filter generator. The map property attribute is the name of the managed property which we're going to use within our filter. In our case, we're going to set it to size, which is the property that SharePoint uses for file sizes. We then add a custom filters element and set the mapping type to range mapping, and the data type to numeric, and the value reference to absolute. Using custom filter nodes, we define each size range using the notation you see here in the slide. For the first and last values, leaving the first and last value empty after the 3 dots means there is no boundary on that side of the range. After our edits to the document are complete, we copy the text back into the web part and apply and save the changes to the page. Here are the final results. Note in the left image, we have our file size category, which indicates we have files within sizes medium, large, larger, and huge. Clicking on the large link, we can see on the image on the right, the query now returns the same results, however filters the documents which have sizes between 500K and 2 meg. In this section, we'll introduce you to custom ranking models. Custom ranking models allow administrators to use XML documents to describe new ways of directing search to rank results. Creation of a new XML model allows specialized search applications to create a unique model targeted to their business requirements. Out of the box, SharePoint 2010 Search contains several ranking models. However, it isn't possible to customize these models directly. Ranking models are identified by their ID. Once a model has been added to the search service application, its ID can be used within the core results web part by setting the default ranking model ID property. This will instruct search to use this custom ranking model when returning search results. You can manage ranking models through PowerShell or by using the relevance object model. There are two options for getting started creating ranking models. First, you start with the default list of static and dynamic features in the linear model by downloading the template XML, editing, and then uploading the modified ranking model file, ensuring you change the ID. Or you can just create a new model in XML which conforms to SharePoint's ranking model schema. The only supported features within the default model are distance, min span, and document length. It's important to note custom ranking models are not versioned, and any updates or changes to a model override the existing model. We began this module with an overview of search extensibility options. We then looked at how developers can extend the search web parts and discussed the query syntax improvements available in SharePoint 2010. We took a look at the new connector framework, and we covered customizing refiners. Finally, we finished up the discussion of custom ranking models. This concludes this module. I'd like to invite you to take a look at some of the other Ignite content for SharePoint 2010.